German armor and artillery dominated the tactical doctrine of the era. Yet the decisive psychological fracture on the battlefield came from American infantrymen operating an entirely new weapon. Ordnance engineers established the baseline for this paradigm shift in 1919 at Springfield Armory. How to automate the reload cycle without exceeding the strict weight limits of an infantry weapon. Engineers utilized the thermodynamic waste of the fired cartridge. The semi-automatic rifle dictates that expanding powder gas directly drives the internal mechanism. Upon ignition, internal chamber pressure instantly spikes to 50,000 pounds per square inch. At this extreme threshold, timing becomes the absolute critical engineering barrier. Unlocking the bolt a millisecond too early means catastrophic receiver failure. The sequence demands ruthless mechanical precision. 4 distinct micro-actions execute in a fraction of a second. Zero shooter input. High-pressure gas bleeds into the cylinder, forcing the operating rod backward. The extractor rips the expanded brass casing from the chamber and ejects it. The retreating bolt completely overrides and cocks the heavy hammer. Finally, the compressed return spring violently drives the bolt forward, stripping a fresh cartridge from the magazine and locking it into battery. The operator experiences only the sharp physical recoil. The auditory signature is a continuous, aggressive metallic clank. Fire. Reacquire. Fire again. The War Department assigned M1 Garand to solve this thermodynamic puzzle. A civilian gunsmith. His strict objective was to design a semi-automatic system rugged enough for mass military deployment. The physics appeared straightforward on paper. The mechanical reality proved hostile. Creating a functional mechanism took months. Transforming that initial prototype into a stable, field-ready platform consumed nearly 2 decades of continuous redesign. While Garand spent years attempting to stabilize his automatic cycle, global military doctrine remained static. By 1936, the world relied on a strict mathematical limit. Fire. Lift the bolt handle. Pull back. Eject the brass. Push forward. Lock. The rigorous muscle memory of manual cycling defined the infantry. A perfectly drilled soldier peaked at exactly 15 aimed shots per minute. This absolute ceiling stood unchallenged since the First World War. Every major military power standard-issued bolt-action rifles. The hardware itself enforced the bottleneck. The standard 5-round stripper clip of the model 1903 Springfield mechanically capped the base fire density of an entire platoon. Exceeding this operational limit was structurally impossible. The stagnation was a deliberate calculation. Planners concluded that individual rifles could not decide an engagement. Heavy machine guns dictated the battlefield. Riflemen functioned primarily as operational shields. They advanced under sustained suppression. They protected the critical machine gun crews. The rifle existed only to keep the operator alive while the heavy weapons dismantled the enemy. 15 manual rounds per minute satisfied this auxiliary role. The United States War Department officially authorized the tactical dismantling of this global standard. The attempt to surpass the doctrinal 15 rounds per minute led to the primer-actuated system. This mechanism proved critically vulnerable to ammunition logistics. Why did a brilliant primer-actuated design, functional in laboratory testing, experience massive failures upon changing the propellant? The mechanism demanded strict physical tolerances. Firing pin strikes. A microscopic shift occurs in the brass primer at the base of the casing. The capsule moves backward under extreme chamber pressure. It transfers a precise kinetic impulse to the bolt mechanism. The action cycles. But field logistics lacked laboratory consistency. Different facilities manufactured improved military rifle powder with varying burn rates. The internal pressure fluctuated. The system jammed. Engineers abandoned the concept. They built a muzzle cup system. This setup trapped expanding gas at the barrel exit to drive a piston rearward. The Ordnance Department evaluated the prototype. Then the military changed the ammunition standards. The Army initially utilized the M1 cartridge. It weighed 172 grains. The heavy boat-tail bullet demonstrated exceptional long-range ballistics. It consistently exceeded the physical safety limits of American military training facilities. The War Department demanded an immediate downgrade. They introduced the M2 ammunition. It weighed exactly 150 grains. This specific weight reduction caused the critical failure. The lighter bullet exited the muzzle at 2,800 feet per second. The heavier M1 round generated a specific pressure curve inside the barrel. The lighter M2 round completely broke the millisecond precise timing of the automation. Gas pressure dropped. The muzzle cup failed to capture sufficient energy. The bolt stopped moving. Changing a single ballistic variable nullified the entire operational cycle. The new ammunition standard eradicated exactly 2 years of development. Following the ammunition redesign, the finalized automated system entered the Second World War. It confronted the German engineering benchmark, the Karabiner 98K. The Wehrmacht deployed highly advanced mechanized forces. Yet standard German infantry formations fractured against one specific rifle. What was the exact mathematical advantage of the American shooter over the German infantryman? The defining metric was cycle time. The M1 Garand completely eliminated manual extraction. A German soldier manually cycled the Karabiner 98K, firing, unlocking the bolt, pulling the handle, ejecting the brass, chambering the next round, locking the action. Each physical step consumed critical milliseconds and disrupted sight alignment. The M1 Garand automated this entire sequence. High-pressure gas executed the kinetic cycle. The shooter simply pulled the trigger 8 consecutive times. This generated a continuous rhythm of shots without mechanical pauses. For the receiving enemy target, these rapid individual detonations merged into a single continuous and overlapping burst. General George Patton assessed this exact individual firepower density as the greatest battle implement ever devised. This technological shift destroyed traditional combat mathematics. German field reports consistently logged heavy machine gun fire, suppressing their front lines. But no American machine gun crews operated in those exact sectors. The suppression came from standard infantrymen executing basic semi-automatic engagements. Manual squad tactics became mathematically obsolete. The mechanism that dismantled German infantry doctrine in 1944 originated from a single aperture, a hole drilled directly into a steel barrel in 1932. How does a complex kinetic system survive freezing mud? The solution required the precise redirection of high-pressure propellant gases. The engineering breakthrough bypassed fragile recoil operations. Designers placed a gas port exactly 4 inches from the muzzle. This specific placement tapped into the pressure curve at its optimal threshold. When a cartridge fired, expanding gases bled downward through the port. The pressure slammed into a stainless steel piston. The operating rod violently cycled rearward. The bolt rotated. The lugs unlocked. The spent brass ejected. The cycle reset. This mechanical calculation prioritized extreme operational tolerances. Competitors submitted rifles with tight internals. Freezing mud and carbon fouling turned those precision mechanisms into useless clubs. The Garand design ignored them. It forced its way through grit via sheer calculated gas pressure. The military demanded absolute reliability to replace aging manual actions. It took 13 years of iterative prototyping at the Springfield Armory. Engineers discarded rival systems, including the Pedersen toggle lock design, due to its strict requirement for wax-lubricated ammunition. In 1932, the gas-operated prototype faced formal Ordnance Department trials. It passed the endurance parameters. 4 years of subsequent competitive testing finalized the configuration. In 1936, the M1 Garand was officially adopted. Across Europe and Asia, military establishments continued to rely on late 19th century bolt-action concepts. The United States became the first major military power to equip its standard infantrymen with a semi-automatic weapon. The official adoption of the system in 1936 established a critical mathematical disparity against the German Karabiner 98K. The manual bolt action yielded 15 rounds per minute. The American M1 Garand delivered 16 to 24 aimed rounds under sustained fire protocols. What do these numbers mean in close combat? The absolute absence of pauses for mechanical reloading between trigger pulls. To operate a traditional rifle, a physical reset is mandatory. The shooter must break their firing grip. The hand abandons the wrist of the stock. The bolt is cycled. The Japanese Type 38 Arisaka shared this exact biomechanical limitation. The British Lee Enfield offered a theoretical advantage. Its cock-on-close mechanism allowed a highly trained operator to approach 30 rounds per minute during optimal test conditions. But maximum cyclic rate does not equal effective combat output. Even the efficient Lee Enfield required the operator to disrupt their line of sight. The physical manipulation of the bolt forces the weapon off target. Realignment consumes time. Time creates a tactical deficit. The gas-operated cycle eliminated this equation entirely. No hand movement, no manual reset. The semi-automatic mechanism processed the recoil and chambered the next cartridge autonomously. This mathematical advantage multiplied rapidly as engagement distances shrank. The infantryman pressed the trigger and engaged sequential targets without ever breaking visual control over the battle space. This uninterrupted engagement rhythm dismantled established combat protocols. A technical superiority of 16 to 24 rounds per minute rendered the fundamental tactics of German machine gun crews mathematically obsolete. Wehrmacht infantry doctrine relied on a single center of gravity. A standard 10-man Gruppe operated entirely around one core weapon. The primary gunner fired the MG-34 or the later MG-42. The remaining riflemen functioned as a logistical support mechanism. They secured the flanks. They carried heavy ammunition belts. Their own Karabiner 98K rifles provided minimal offensive output. The operational logic utilized a strict mathematical calculation. German tacticians assumed opposing infantry also utilized bolt-action platforms. The high cyclic rate of a German machine gun, often exceeding 1,200 rounds per minute, would theoretically suppress any bolt-action element. The semi-automatic volume of the M1 Garand shattered this formula. American platoons returned concentrated fire without mechanical pauses. The distinct reports of individual rifles merged into a continuous, overlapping roar. German after-action reports frequently misidentified this dense concentration of infantry fire. Intelligence officers classified it as the work of heavy, crew-served machine guns. The suppression paradigm inverted. To cycle the Karabiner 98K under this volume of incoming fire, a German soldier had to break his profile. He lifted his head from defilade. He physically worked the bolt. Under the dense grid of American semi-automatic fire, that fraction of a second of exposure became fatal. Infantrymen could not maintain visual contact long enough to reacquire targets. A macro doctrine built for a continent failed at the tactical level. The foundational suppression equation collapsed against an 8-round system. The continuous fire that suppressed the MG-42 crews relied entirely on one physical component: the 8-round en-bloc clip. Did the ring of the ejected clip become a deadly signal to the enemy? Post-war surveys of veterans proved otherwise. Soldiers pushed the stamped steel carrier directly into the open receiver along with the ammunition. This metal frame became an active part of the feed mechanism until the rifle fired the final cartridge. Then, the internal mechanics took over. The bolt locked open automatically. The receiver forcefully expelled the empty container. A sharp metallic ring of stamped steel flying from the weapon, the ping. Decades of popular myth framed this acoustic signature as a critical tactical flaw. The theory claimed German and Japanese troops memorized this specific noise during close-quarters combat. A brief acoustic window. A signal to strike before the American could reload. Statistical data dismantled this narrative. Post-war interviews with German and Japanese veterans revealed the truth. Infantrymen rarely heard the ejection sound during actual firefights. The overwhelming noise of combat masked the frequency completely. Instead, American soldiers utilized the sound themselves as an immediate auditory prompt to reload. The ping was never a vulnerability. It was simply the acoustic byproduct of a relentless suppressive rhythm. 8 uninterrupted semi-automatic shots. Riflemen stripped a fresh clip from their belt and seated it in seconds. The cycle repeated. Captured M1 Garands reached German ordnance laboratories. Technical assessments confirmed the critical obsolescence of standard German doctrine. Within 15 years, this exact mechanical reality would force global militaries to abandon bolt-action rifles forever. Officers dismantled the American gas cylinder. They documented the standardized production stamps. They calculated the necessary tooling requirements. Mass duplication was impossible. Could the depleted industry of the Reich respond symmetrically to the American system? The initial engineering answer was the Gewehr 41. Designers implemented a complex muzzle gas trap. The heavy metallic clank of the forward device physically disrupted the weapon's balance. The unloaded rifle weighed over 10 pounds. Environmental stress caused immediate reliability failures. It never displaced the standard Karabiner 98K. The subsequent Gewehr 43 required external solutions. An acute engineering crisis forced the Reich to extract the short-stroke gas piston directly from captured Soviet SVT-40 rifles. The copied mechanism functioned, but the industrial mathematics failed. Manufacturing shortcuts became unavoidable as infrastructure collapsed. The Reich managed to assemble fewer than 500,000 units of the Gewehr 43. Across the Atlantic, American factories capitalized on the initial 1936 procurement decision. Facilities operated without interruption. A tenfold industrial superiority fundamentally closed the technological gap. Total wartime production by American industry reached exactly 5 million. During the Korean War, the exact gas-operated mechanisms that had suppressed German infantry in Europe faced the critical temperatures of the Korean peninsula. Winter metrics dropped to -30 degrees Celsius. Standard weapon grease crystallized. Frozen lubricants locked the receiver assemblies of conventional firearms, converting high-precision mechanisms into useless steel clubs. The Garand mechanism cycled. The extreme cold isolated the design variables. The platform automation functioned exclusively due to the excessive kinetic energy generated by its heavy gas piston. The structural margin was absolute. The 15-year development cycle validated its mechanical endurance. This specific gas system survival dictated the next procurement phase. In 1957, the military standardized the M14 rifle. The new platform introduced a detachable box magazine. It added selective fire capability, but the core architecture remained identical. The weapon operated on the exact same rotating bolt. The engineering DNA remained intact. The Department of Defense maintained John Garand's original base specifications and issued these exact mechanical solutions to American infantry squads well into the 1960s. The mechanical solutions retained in the M14 represented merely a localized phase. The 1936 specification codified the actual global baseline. Why, after the end of the Second World War, did no major army on the planet return to the bolt-action system? The mathematics of engagement had fundamentally changed. One rifle dictated a global systemic shift in infantry fire density. The transition from manual bolt operation to gas-operated semi-automatics permanently altered combat calculations. Base cyclic rates escalated. A standard infantry squad shifted from 15 to over 40 aimed shots per minute per operator. Semi-automatic capability became the absolute minimum. The assault rifle became the structural destination. Subsequent platforms like the AK-47 and the M16 did not utilize Garand's specific internal mechanics. They answered the exact operational requirement he forced the military to confront in 1936. Infantrymen required an uninterrupted volume of fire. Manual extraction failed modern requirements. The doctrinal victory remained absolute. General Patton evaluated this definitive shift in combat output. He deliberately bypassed standard ordnance nomenclature. Patton classified the Garand not simply as a rifle, but specifically as a battle implement. Logistics commands globally rewrote their inventory lists. After the Second World War, no major military force on Earth ever issued a bolt-action rifle as their primary service weapon.